So we will use method of integrating factor. dt over dt equals negative k times t minus ta. Distributing this negative k to this, it will be dt over negative k of t plus kta. And we will rewrite this to its standard form, where dt over plus k of t equals kta. We will find the integrating factor of the mu or the mu of t, e raised to the integral of k dt equals e raised to kt. The integral of e raised to kt times kta dt plus c over the mu or the integrating factor e raised to kt. We will have ta e raised to kt plus c over the integrating factor or the e raised to kt. We can write this as ta e is kt over e kt plus c over e kt. We can cancel this out, and ta plus c over e kt. I'll ask my friend for the verification of the system.
Hello?
Bianca, could you verify the correctness of the system of TE that I have formed using another method?
Sure. Send me the problem. So the given system of differential equation is dt over dt equals negative k times t minus ta. Then we will use the method of separation of variables and come up with dt over t minus ta equals negative k times dt. Then we will get its integral and get ln t minus ta equals negative k dt plus c. Then we will place both sides of the function on the exponents of e and come up with e raised to ln t minus ta equals e raised to negative kt plus c. This will be cancelled, so we will be left with t minus ta equals e raised to negative kt plus c. Then we will transpose negative ta, then it will be equal to ta plus e raised to negative kt plus c. Distributing this, we will get t equals ta plus e raised to negative kt times e raised to c. This is equal to c, so we will be left with t equals ta plus e raised to negative kt times c, which is equal to the system of differential equation that my friend has gathered, which is t equals ta plus c times e raised to negative kt. Good evening, sir. Can you help me verify the correctness of the equation that I have for you?
Okay, I'll try.
Thank you, sir. I'll just send it to you.
Newton's law of cooling is defined by this equation. So let's try to find the solution to this differential equation by using exact equations. Let's separate the small t from the big T. So we get dt is equal to negative k T minus ambient temperature dt. So we transpose this to the other side and equate it to 0. And now we get m and n. So we can now use exact equations. Partial derivative of m with respect to small t is equal to 0. The partial derivative of n with respect to big T is equal to k. From what we can see here, we know that these two are not exact. Therefore, we need to find the integrating factor to make this equation exact. To find the integrating factor, we take partial derivative of m with respect to small t minus the partial derivative of n with respect to big T divided by n. And solving for this, we get 0 minus k divided by k T minus ambient temperature. Simplifying, we get negative k divided by k T minus ambient temperature. We can cancel both these, leaving us with negative 1 over T minus ambient temperature. Now that we found the integrating factor, we need to plug it into the equation. T is equal to e raised to the integral of what we found, negative 1 over T minus TA d big T. Solving, we get e raised to negative the natural logarithm of T minus TA. And then we get T minus TA raised to negative 1. So we got the integrating factor. Now we just need to multiply it with the original equation. dt plus k T minus TA dt is equal to 0 multiplied by T minus TA is to negative 1. This gives us 1 over T minus TA dt plus k T minus TA dt divided by T minus TA. This is equal to 0. So we can see that this both of these cancels out. We are left with 1 over T minus TA dt plus k dt is equal to 0. Now that we found our exact equation, we can now integrate m and n. This gives us 1 over t minus ta dt plus the integral of k dt is equal to the integral of 0, which is c. We know that du over u is equal to the natural logarithm of u, and that is represented in this form. So the integral of this expression is ln of t minus ta, and add it to the integral of k dt, which is kt. Is this equal to c? Transpose kt to the other side, leaving us with the natural logarithm of t minus ta is equal to c minus kt. And then we exponentiate both sides by t. This gives us e raised to the natural logarithm of t minus ta is equal to e raised to c times e raised to negative kt. We know that e raised to c is still a constant, so we can rewrite ln t minus ta is equal to c e raised to negative t. And we know that this both cancels out, which means t minus ta is equal to c e raised to negative kt. We transpose the ambient temperature to the right side, leaving us with t minus T is equal to Ta plus Cd raised to negative kT.
So we all know that the initial temperature is 90. So we plug in the values that we get from the system that we have, where T is equal to 90 and the ambient temperature is 20. Transposing the 20 minus 20 negative k 0. We will get 70. So after 3 minutes, the soup cools down to 70 degrees. And applying again the system that we take, we have 70 as 30 and 20 plus 70 e raised to negative k. So we will have 70 minus 20. So our goal is to find k. We will divide both sides to 70. So we will get the natural logarithm of both sides. Applying LN, we will get and to get the negative k, to find k, we'll divide both sides to 3. So this side, so this will cancel and negative k. And getting this value, we will get 0.112. Where k is equals to 0.112. So these are the values that we have gotten. So for the time take for the circle, we will use the resistor.
Nakabis combination. Tapos pabalik sa ano, 26 doon. Sinamak na tawa na ako. Galing ko kung dami na sa akin. Tapos sabi ko, max-up yung ganyan ng baba. Tapos din doon yung baba kasi nakita nila. Oh, dito sa ganito.
Solving this, we will get 0.11. So